Okay, obviously, guys, the purpose of doing these quizzes is not to greatly affect your mark. Okay, as you probably noticed, once your lab mark went in, your quizzes were basically, they don't matter anymore. Okay, quizzes are hardly worth anything. The purpose of quizzes is to be able to review material that we've been going over. All right, and also to give you an idea of your level of mastery of that material. So to that end, when you look in Power School at your marks, if you open up a specific task, especially a quiz, you will notice that near the bottom in the description of that task, okay, there will be 2 links on every quiz. Okay, one link takes you to this file. Okay, the one that you looked at that I gave you last night that you could go over it beforehand. Okay, so it'll take you to the quiz questions, and that's what it'll be called. Quiz whatever number of questions. Okay, and then a second link that says podcast of quiz whatever. All right, the idea here is that if you do poorly on a quiz, that you can go back and review it. All right, so when you're studying for your unit exam in a few weeks, okay, that would probably be one of the things you're going to want to do. Is look at your quizzes and go, you know what, I didn't do very well on that quiz. I'm going to go back now and see if I do better on it. And then you can see if you did by watching the podcast where obviously I go over the answers. Okay, that's the reason I put them there. Okay, so that is something that you should do, okay, as part of the review process when you're preparing for an exam, especially your unit and final exam. Okay, your final exam is a really big one, so you know, that's a good idea for that one. All right, question number 1. Okay, we have beryllium reacting with oxygen to produce beryllium oxide. If their reaction looks like that, give them a mark. Yes, it does. It needs to look like that. Okay. If they wrote oxide, guys, remember, O2 is not oxide. That's how oxygen comes as an atom, or as an element. Okay, this is oxygen, O2. Okay, we only use "ide" if it's in a compound with something, and that's when we change the name. Okay. What kind of reaction is this? I got 2 elements combined to form a compound. This is a synthesis reaction. 1 mark for that. And now I need to balance it. Sorry, okay. What do they have instead? So they have beryllium, oxygen, and they don't have an arrow. Okay, today, in the future, we got to have at least a plus or something in there that indicates they're not the same compound. Yeah. All right, does everybody follow there? Okay, when we're writing, you don't have to write in beryllium reacts with oxygen, but just have a plus there so I know that they're separated. Yeah. All right, now I got to balance it. The only thing that's not balanced right now is oxygen. Okay, so that requires a 2 right there. But when I do that, it gives me 2 berylliums, so a 2 is required over there. Okay, 1 mark if they have that for the balancing. Questions on number 1. So it's out of 3 marks. Each one will be out of 3. All right, our second one, we have calcium carbonate reacting with lithium to produce lithium carbonate and calcium. Okay, 1 mark if their reaction looks like that. Okay, I have an ionic compound reacting with an element to produce a new ionic compound, different element. Reaction is single replacements. 1 mark for single replacements. I'll give it to him today, but I won't in the future. Okay, now I've got to balance it. So looking at what's not balanced right now, the only thing right now that isn't balanced is lithium. Okay, there's 1 carbonate on this side, 1 over here, 1 calcium, 1 calcium. Okay, all I need is a 2 here, and the equation is balanced. Okay, so 1 mark for the balancing. That one's also out of 3. Questions on number 2? All right, number 3. And this one, guys, is probably going to get a few people, because if you recall, yesterday I went over several examples that involved this, and each time I did, I mentioned this is something people will forget when they do this, and it's the Roman numerals on multivalent metals. Okay? Iron, Roman numeral 2 on this one. Oxide is reacting with sodium bromide to produce iron 2 bromide and sodium oxide. The reaction has to look like mine or they don't get the mark for the reaction. Okay? All right. Now, something I'm pretty sure I mentioned this yesterday, but I'll mention it again, and that is that you don't have to figure out the Roman numeral more than one time. Okay? If it's iron 2 on the reactant side, it's iron 2 on the product side. Okay? That doesn't change. And that's important because when we get to predicting the products, we have to keep it the same. Otherwise, we're guessing, okay? And we don't want to be doing that. So the type of iron or any other multivalent metal does not change between the reactant side and the product side. All right. Ionic compound plus ionic compound gives two different ionic compounds. That is a double replacement reaction for 1 mark. And then we have to do some balancing. Right now, the largest numbers are 2s on sodium and bromine. So I'm going to go over here and balance my sodium, which balances my bromine, and everything else is good. Okay, 1 mark for that one. Questions on number 3? Okay, moving on down to number 4 here. Okay, I have copper 2 nitride. So copper is Cu. The Roman numeral tells me I'm dealing with the 2+ variety. Okay, nitride is always -3. So I have Cu3N2 breaks down into nitrogen gas and copper. That's what the reaction's got to look like. 1 mark for that. And here's the really unfortunate part. If they forgot that N was a 2, or they didn't drop and swap copper 2 nitride, they're not going to get the balancing numbers correct either. Okay? So what kind of reaction is this if I got 1 reactant only? Decomposition, so they can have 1 mark for decomp. Okay, now I've got a balance. Nitrogen's already balanced, so that's good. Okay, copper's a 3, copper's a 3. We're done on the balancing. Okay, so we kind of had easy balancing ones so far. All right, questions on that one? All right, number 5. I gave you the formula for heptane, okay, because I didn't want you to have to guess what it was. Okay, so we have C7H16. Okay, burns in the presence of oxygen. That's pretty much a dead giveaway on the reaction type. Combustion. Okay, what are the products always of a combustion reaction? CO2 and water. Now, I did have, the question came up, should I write this one as HOH? In this case, no. Okay? You should only write water as HOH if you're dealing with an ionic reaction, a replacement reaction of some kind, because then you're going to have an OH on one side and it's easier to track. In this case, it isn't. To write it as OH is actually going to be more confusing in a combustion reaction. So write it as H2O in these. Okay? All right. Special rules for balancing combustion reactions. Balance alphabetically in the rule of 2. Do they both apply here? No. Okay? Only the balance alphabetically applies here. 7 carbons. 16 hydrogens. 16 hydrogens. Now I've got to do the oxygen. 7 times 2 is 14, plus 8 more is 22. 11 times 2 is 22. Okay, out of 3 marks. 1 for the balancing, 1 for the reaction, 1 for the type. Questions on number 5? Okay, number 6. Potassium permanganate. That's that purple stuff that turns your skin brown. Okay? Is KMNO4, because K is +1 and permanganate is -1. Okay? Reacts with magnesium hydroxide. Okay? Magnesium's a +2, hydroxide's a -1, so when we drop and swap, we require brackets. All right, and what's going to happen is the metals are going to switch, so potassium is going to end up with hydroxide, and magnesium is going to end up with permanganate. In that way. The reaction must look like that in order for them to get the mark. So, how important is being able to write formulas correctly? Absolutely crucial. Okay, absolutely crucial to be able to drop and swap and do that kind of thing. Claire? No, 3 marks. They're going to get 1 for the reaction, 1 for the type, and 1 for the balancing. Yeah? Good. Okay. What kind of reaction is that since everything's ionic? Double replacement. Okay, 1 mark for double replacements. All right, and then we got to balance this thing. Right now, there's 2 hydroxides over here, but there's only 1 over here. So I'm going to put a 2 there to balance the hydroxides. And when I do that, it gives me 2 potassiums. So I've got to go back over here and balance my potassiums. When I do that, it gives me 2 permanganates. There are already 2 permanganates on the other side, so that's good. Okay, and then I've got magnesium, 1 of them, 1 of them. Now we're good. Okay, questions on those? All right, before you do anything like handing back or anything, I want to have a look at number 7. Obviously, you're not giving marks for number 7. I just want to look at how a predicting process works. All right, so in this reaction here, I have an ionic compound in calcium chloride reacting with another ionic compound in iron 3 bromide. What's the only kind of reaction that starts with 2 ionic compounds? Okay, a double replacement. What happens in a double replacement reaction? Sydney. The metals switch partners. Okay, in a double replacement reaction, I have to get 2 new ionic compounds on the other side. The only way to do that is just to swap the metals. Austin. It does not matter which order the compounds go in on the other side, no. Okay? It does matter that the metal is first and the nonmetal is second, but beyond that, no, it doesn't matter. Okay? All right, so I'm going to say then that I swap the metals. Okay? Iron's new partner is going to be chlorine. Okay? Since iron was a 3+ over here, it's also a 3+ over there. So it'll be iron and 3 chlorines. Okay? And calcium is now going to be with bromine. Okay? Calcium's 2+. Bromine is 1-, so we're looking at CaBr2 on the other side. So now I've predicted the products. Was that very hard? Not really. I mean, all I have to do is know what happens in each of the 5 reaction types. As long as I know what happens, it's easy to put the things together on the other side. Remember, you can thank Dalton for this. His atomic theory says you can't make new substances in a reaction. All you can do is separate, join, or rearrange. Okay? Dalton's atomic theory says predicting the products of a reaction should be easy. Now, we're not done. What have we not done to this? We haven't balanced it yet. Okay? So over here, I'm going to need 3, 2, 2, 3. Not as hard as maybe you thought. Okay? It's out of 18. Give them a mark out of 18, put it at the top, and bring them up to me, please. Okay, guys, just a couple here. Well, one for sure right now that I want to go through, and another one that I'm going to go through here in a few minutes. The first one I want to go over is number 9. Okay, number 9 gives people fits in the balancing. The reason it does that is because oxygen is in all 3 places in the reaction. It's in both reactants and in the products, obviously. Okay, but what often happens is people forget about this oxygen over here that's on carbon monoxide when they're doing their balancing over here. Everybody follow me on that? Okay, so here's what we've got to remember. Okay, we've got to remember that there are, on this side right now, 3 oxygens, and on this side only 2. So what's the lowest common multiple of 3 and 2? 6. All right, so what I'm going to do is that I'm going to put a 2 here. and just see what happens. I know that doesn't equal 6, okay? But I've got what we often refer to in chemistry as the odd-even problem, okay? And that is that I have an odd number of something on one side and an even number on the other. Everybody follow me there? How do you make an odd number even? Multiply it by 2. Think about it, okay? Any odd number, you multiply it by 2, it becomes an even number. Right? So what I'm doing is I'm multiplying this by 2 so that now I have an even number of oxygen atoms, because now it'll be easier to balance it. Okay? I've got 2 carbons over here, and now I've got 2 carbons over there. That gives me 4 oxygens. How many oxygens do I have over here? 4. 2 here and 2 here. And I'm done. Okay? That's going to come up fairly often. So if you're balancing a reaction and you find you got the odd-even problem, okay, the best thing to do is to double whatever number you started balancing it with, and it'll usually go away. Okay? That's the solution to the odd-even problem. Okay, so those are the 2 corrections to the mistakes on the keys. Okay, number 1, change from 2Cl to Cl2, obviously. Okay, and for number 3, it was just generally bad. Okay, and that's the correct answer for it now. Okay, let's have a look at number 5 here, because number 5 is going to have a similar problem to that odd-even problem that we talked about before. Okay. See, somebody's not looking at the clock.
Guys, sorry for the interruption. That bell went 10 minutes early. Can you please make your way back to your first period class? Period 1 actually goes till 9:55. So everybody please make their way back to their first period class. That bell went early. Everyone back to their first period class, please.
Okay, so we got nitrogen trihydride, NH3, okay? And it's reacting with oxygen, which always comes as an O2, okay? And that is going to produce nitrogen and water. Okay, I need to balance this, and right now I've got a couple of problems, okay? The first problem is that I got an odd number of oxygens on one side and an even number on the other, and an odd number of hydrogens on one side and an even number on the other, okay? So those 2 are problematic. Nitrogen, however, may not be problematic, so I'm going to start with it and see what happens, okay? I'm going to put a 2 here to balance my nitrogens and just see what happens, okay? That gives me how many hydrogens? 6. So if I go over here and make this 6, does that help my oxygen odd-even problem? It does not. Okay? I have 3 oxygens on one side, 2 on the other. My odd-even problem still exists. So a 2 didn't work here. The 2 produced an odd-even problem. What should I do to it? Double it. All right. Okay? If you double an odd number, you're going to get an even number. So I'm going to make this a 4 instead and see what happens. Now, if you keep doubling, what you always want to check for when you finally get it to work is that you can't reduce it. Sometimes you double it too much and you could actually reduce the numbers down. Your balancing does always need to be in the lowest terms. All right, I've got 4 nitrogens over here. Now I've got 4 over there. I've got 12 hydrogens. Now I have 12 hydrogens and, luckily, and now an even number of oxygen atoms. 6. So if I go back over here, I have 6 oxygens, and I can't reduce that because I can't divide everything by one number. So that is the lowest common term. Okay, that is it balanced. Again, if you run into that problem where you have an odd number and an even number, double whatever your starting number was, and that will take care of it. Okay.